Okay, so anyhow, yeah, pretty much everybody got 2 squared, that's 4. Negative 2 squared means negative 2 times negative 2, which is 4. Okay? Now we got 3 of them with negative exponents, to which I only saw about 1 right answer. Okay? 0 squared, well, that's 0 times 0, and that's 0. People get that. 0 and another negative exponent. We'll get that in a minute. Square root of 4 is 2. It's not 2 or negative 2. It's 2. Okay? Now the confusion comes from this, and this is worth noting. Okay, let me go ahead. Oh, I've got the camera on. I'm starting to forget things. Too many things going on. Okay, so square root of 4. Now, if you have the equation x squared equals 4, the solution is not x equals square root of 4. Okay? There are 2 solutions, 2 and negative 2, right? That's clear, because if you square 2, you get 4, and if you square negative 2, you get 4. Okay? Because, we just saw if you square negative 2, you get 4. Okay? X is, so you could say x is square root of 4, or x is negative square root of 4, or you could say x is plus or minus the square root of 4, which of course is plus or minus 2. Meaning it's 2 or negative 2, right? But the square root of 4 is not plus or minus 2. Okay? Solution to x squared equals 4 is plus or minus 2. Okay? I'm glad you're thinking about the plus or minus. That's important. A lot of people just kind of let that one go over their heads. Okay? Again, something I can't conceive of from people who've had the prerequisite courses, but it happens. Okay, square root of negative 4 is 2i. It's not a real number. Everybody know what I means? How many know what I means? Okay, another thing I can't conceive of, solve quadratic equations. Everybody know the quadratic formula? Well, actually, I went to a pretty high-level school of science and engineering. Didn't even offer biology, just hard sciences and engineering, chemistry, physics, and metallurgy, and engineering stuff, and mathematics. So, it's, and I did pretty well in my SATs. So they actually put me in a course with a real professor instead of a graduate student. And even in that class, I think I was one of the minority who knew the quadratic formula, which kind of confused me because it's pretty, on the level of Virginia Tech's. The Virginia Tech and Case were, well, actually Case was rated way ahead of Virginia Tech, but Case is private, Virginia Tech is public. And Virginia Tech is going up in the ratings, and Case is going down. It's still top 50 school, but not what it was. So anyhow, probably top 10 school of science and engineering in the country. Not nearly as good as MIT and Stanford and a couple of others. It's kind of in the second tier, but pretty high in the second tier. So my point is, even then, in the good old days, there were people who didn't understand what I thought any anybody with an IQ above 14 would understand. Okay? Which is a quadratic formula. And then, you know, my algebra is pretty good. There's some things I didn't know. And there are a lot of people who know a whole lot more than I did. My point really is, if you don't know the quadratic formula, don't feel badly. But if you come out of this course and don't know the quadratic formula well enough that you'll never forget it, there's something wrong with you. Okay? We'll get to that shortly. So don't feel bad about that. Don't feel bad about the things you don't understand, but fix that. Okay? Now, negative exponents. I mean, you got your rules of exponents. One of them is that a to the negative b is 1 over a to the b. Okay? And you know, a lot of you still looking like, oh, never saw that before. Makes me wonder about the SOL and the people who designed it. I won't go into that again. Okay. So 2 to the negative 1 is 1 over 2 to the 1. And of course, 2 to the 1 is just 2, so that's 1/2, right? Okay? And 1/2 to the negative 1 is 1 over 1/2 to the 1, which is 1 over 1/2. And that's a complex fraction. Now, fractions are something else. You learn them in 5th grade and you never use them again. You got a calculator does it for you, so you don't understand fractions, which is a real handicap when you get into this course. A little later on, we do rational functions. So we've got to fix that, but I find that you know, the stuff we're going to do seems to fix it pretty well. Okay? And it usually comes out kind of okay. Okay, so anyhow, 1 divided by 1/2. How do you do that? Well, you can write that out. 1 divided by 1/2, and that's 1 times 2 over 1, which is 1 times 2 over 1, which is 2 over 1, which is 2. And most people skip a lot of steps in between there. Once you see 1 times 2 over 1, well, 1 times whatever is the whatever, and all that. The main thing is you got to know this means this, and to divide by a fraction, you multiply by the reciprocal. Is that familiar? Okay. Some of you look kind of dubious, and that's consistent with what I usually see. Okay. 5th grade mathematics, and people don't know it because it never got reinforced. Not because it's not because it's hard. It's not hard. It's just people forget it because you haven't had to use it. Which, again, leads me to the conclusion the curriculum's absolutely ridiculous. Okay? Not in everything. Okay? In mathematics, there's some serious problems. Okay, anyhow, that's 1 over 2 to the negative 2 is 1 over negative 2 squared, which is 1 over 4. Okay? Okay, so now I want you to make a series of tables. Just deciding, we probably need to write it there so everybody can see it. Okay, you got negative 2, negative 1, negative 1/2, 0, 1/2. Oh yeah, there's one I didn't do. 0 to the negative 1. Well, that would be 1 over 0 to the 1, which is 1 over 0, and what's that?
Undefined.
I'm sorry?
Undefined.
It's undefined. Why is it undefined?
Because you can't divide anything by 0.
Sorry?
You can't divide anything by 0.
Why not? Anybody
not
ever
there.
explain why not?
It's just not there. It doesn't exist. There's no hole.
No offense, you're going in circles. You're saying it's undefined because it doesn't exist because you can't do it.
Yeah.
You haven't ever explained why you can't do it, but nobody ever can. Okay? So don't feel bad. And don't feel bad about going in circles. You're giving the best answers you could have. Okay? Well, digressing a little bit, but let's see. What's 1 divided by 0.1? Before I do that, 1 divided by 1/2. What does it mean to divide a number by another? What's 10 divided by 2? 5, right? Why is it 5? Because you memorized it? Well, it's not a bad answer, because that's what you did back in 3rd grade, or whatever, okay? But it's 5 because you go 2, 4, 6, 8, 10. It's this many. Incidentally, research has shown that the whole idea of counting on your fingers when you're small, I've got a grandchild who started kindergarten. They discourage counting in figures. They want you to memorize. Well, counting in figures tells you what's going on. That's a physical connection with the idea of multiplication or division, or addition or subtraction, right? I counted my fingers. Didn't let the teachers see me. I didn't want to get killed. Okay, anyhow, so you know, kids need to count their fingers. They also need to memorize, but the basis is what you get when you count your fingers. Okay? Okay, well, of course, sometimes you don't have enough fingers. You know, some numbers are bigger. Okay, well, okay, so dividing 10 by 2 is basically counting to 10 by 2s, isn't it? Now, 2 divided by 10, when you divide by a bigger number, well, it's kind of the reciprocal thing, right? And it's 1/5. Okay, so you count to 10 by 2s, but it's now in your denominator. Okay, and you can do decimal expansions, and of course, whoever really thinks about arithmetic, if you got a calculator in your hand, which you shouldn't until you're a junior in college. Okay? So, what about 1 divided by 1/2? Well, that means you count to 1 by 1/2, right? So what do? You got 1/2, another 1/2 gives you 1, right? Simple enough, isn't it? Okay. So what's 1 divided by 1/10? Now you got a rule that says you move the decimal over and all that stuff, right? Put a 0 in it, whatever. That's a good rule, although people don't know that very well sometimes. But it's a good rule. But what does it really mean? It means how many of these do you need to make this, right? So it means you can count to 10 by 0.1. 1, 0.2, 3, to 1. I'm sorry, count to 1 by 0.1. 0.1, 0.2, 0.3, 0.4, 0.5. Where was I? Oh yeah, 0.6, 0.7, 0.8, 0.9, 1. It's 10, right? It's 10 because it takes 10 of these to make this, not because of some rule that you use to calculate it, and not because that's what your calculator tells you. That's never a good reason for anything. That doesn't give you any insight, okay? It doesn't give you any ability to apply mathematics, okay? Now, if you've already counted it in your fingers and understand why 1 divided by 0.1 is 10, then by all means, use the calculator to divide 795 by 0.732, okay? You need to do that. You can't count to 795 by 0.732s. You'll make a mistake. Somewhere in the first 100, you'll screw something up, okay? Well, calculators have their use, okay? But they're totally misused, and they're used to bypass understanding. And what we want to get here now is we want to remedy some of that. We want you to understand why things work, because then it's less work to get through this course. Okay? Okay, well, we're trying to figure out why 1 divided by 0 is undefined. Okay, well, what's 1 divided by 0.01? You have enough fingers? 0.01, 0.02, 0.08, 0.09, 0.010, which is 0.1, okay? And it's really not 0.010, it's 0.1, right? So now we're only up to 0.1 after we did 10 of these, right? And we know from this we've got to do that 10 more times, so it better be 100, right? Now you don't have enough fingers, but you can imagine counting to 1 by 0.01. Okay? Okay, now let's try 1 over 0. Okay? Just start counting on my fingers. 0, 0, 0, 0, 0. Every time I get to add 0, but I'm not getting anywhere, right? Okay, I can't count to anything by zeros. Means I can't divide anything by 0. It's impossible. Division by 0 is undefined because of what division means. Okay? Which apparently never gets explained to anybody at any time. It's just a rule that's handed down on a stone tablet, but it's not hard to understand. If you understand division, of course then nobody really past 2nd or 3rd grade or 4th grade requires you to understand what division is. It's just something you punch into your calculator. Okay? Okay, so you want to get out of that mode of thinking, and that's not easy. So anyhow, okay, we're going to go on. Okay, so this is just some stuff about numbers. So now, back to the thing I digressed from. Okay, if x is each of these numbers, what's y equals f of x. Now, if I give you the formula for f of x, you're going to be able to answer that question, right? Okay? So I want you to do this. So you're going to make tables. Let's just start with these 3 functions. Now, to give you some idea of where this is going is, the graphs you have in the graph packet I gave you last time. And it just occurred to me that Erica didn't get a graph packet. He asked me for what I gave out. He gave you the homework assignment, did he give you the graph packet? Okay. The graphs in your graph packet, well, there's 3 of them right there. Okay? Each of those graphs is a function, and those are the functions that we build almost all of mathematics up through the 4th semester of calculus on. Okay? And the functions that are used everywhere, in almost every discipline. Now, there are other functions that most of you probably never see unless you become a mathematician or an engineer or a physicist or something. Okay? And you never have to worry about them. Okay? But by combining these functions, by composites and by sums and quotients and stuff, we get an array of functions that we can build a technological society on. Okay? So we're going to do this, and the one caveat I'll give you is evaluate only if you can get an exact value. If you can't write down an exact value, it's not going to be on the table and you're not going to need it. So here's your table. So write down the table. And I guess one other thing I'd better tell you is that let's just figure out, okay, for f of x equals x squared, what is f of negative 2? Okay? So how do you do this? Okay, now, you know, when I ask people to do function notation, people still tend to get a little confused. Again, don't feel bad about that. I never saw function notation before I went to the university. Okay? Instead of a course in like pre-calculus, I had a course in like logic and set theory. Okay? Very good course. And for my mathematical development, it was much better than pre-calculus would have been. It also forced me to learn pre-calculus while I was taking a very, very tough calculus course. I didn't do that great in the course. I made a C, but that was back when C was actually a respectable grade. The majority of people made C's in the course. I made C's all the way through first year calculus, but I had to figure out pre-calculus as I went. So then in the 3rd and 4th semester of calculus, I made A's. Strong A's, some of the highest grades in the place. I didn't always do that in my subsequent courses, but I did it in those two. And that's not particularly important, but what's important is if you don't really understand function notation, almost everybody did, but I didn't. Okay? Figured it out pretty quickly. Okay, so if f of x equals x squared, what's f of negative 2? Well, we write f of negative 2, which looks a lot like f of x, doesn't it? Except for what? What's the difference between writing f of negative 2 and writing f of x?
You know the value of x?
That's a good way to say it. Well, I would say just in terms of what's written down, I've got a negative 2 where I had an x. So x must now be negative 2, which is what you said. In slightly different words, the value of x is negative 2, and you know that. Okay, not everybody does, not everybody, in a typical, maybe you all do, but in a typical pre-calculus class, people don't necessarily look at it that way. And then we get over here and we get f's in what we have on the right-hand side or something like that. So we want to be clear on the notation and on literally what's happening. X has been replaced by -2. So we have to replace this x by -2. And then you can evaluate it, and of course that's one of the things we evaluated somewhere here, right? And everybody pretty much evaluated that correctly when I asked you to, so, okay? In other words, y'all did pretty much what I expected. You pretty much did most of it right except for the negative exponents. Okay? Okay, so with that, go ahead and make your tables. I'm just going to circulate around. You ought to be able to do this pretty quickly for at least the first function.